Here's another practice quiz on particle motion, or just a massive particle motion problem if you want to think of it like that. And I added a couple of questions down here in the bottom, so sometimes they'll look a little bit different. Some just have the H, but we're going to do the I and the J also and talk about the intervals when the speed is increasing and decreasing. I'll just probably do that a little bit later, but it will be available for you. All right, probably be the third video. Okay, so this is my position function. S of t equals t cubed minus 8t squared plus 5t plus 10. So this is a little more interesting because it's a cubic. So let's get on to answering these questions. First of all, how far? Now you got to be careful. I don't like the how far. Sometimes I see it, but I just should have asked what's the displacement, because this is not really the distance traveled. This is just the difference between where you start to where you finish. That's the displacement. Like we said before, you could go forward, you could pass. You know, in other words, if you went from home to school and then back to home, your displacement would be 0, but you actually did travel. So when we talk about far, we're talking about the displacement. If we talk about the total distance traveled, that's something different, and we'll handle that a little bit later. Okay, so how far? So we want to find the displacement. So it's going to be letter A over here. So let's do our work here. And remember, the displacement is just on an interval, and we're going to be during the first 4 seconds, it says. So we're going to be from 0 to 4. So our displacement will be S of, and remember, this was a little bit different in the notes, but I did tell you that we can use displacement S of B minus S of A if this is on the interval AB. All right, so that'll give us our displacement. Fix this, okay. So that's going to be S of 4 minus S of 0. So now we've got to calculate. So S of 4, and I can do that over here. S of 4, if I put 4 in here, I've got 4 cubed minus 8 times 4 squared plus 5 times 4 plus 10. And 4 cubed is 64. 4 squared is 16. 8 times 16 is 128. And then 5 times 4 is 20 plus 10. If we add this up, 64, 74, 84, 94. So we have negative 128. And then we have got plus 94. So that equals a negative 104, 34. And then S of 0, that's just going to be 0, 0, 0. So that's just going to be 0 minus 0 plus 0 plus 10. So that's just going to be 10. Okay, so this is going to be S of 4, which is negative 34, minus plus 10. And that's going to be negative 44, and that's going to be meters. So there's your displacement. Okay. The next question we can ask is find the average velocity during the first 4 seconds, the average velocity. Well, that's like our average rate of change. And again, on AB, we can say that that's the same thing as, I'm sorry. And that would be, let's say, delta S over delta T. That's the average velocity. And sometimes they can use this notation. So delta S over delta T would equal S of B minus S of A all over B minus A. And we already calculated S of B up here, minus S of A on 0, 4, so that's nice. We can kind of piggyback off of our work here. Okay, I hope that makes sense. So what I'll say is this is going to be, S of B minus S of A is going to be, if I want to write it down, I could. Over 4 minus 0, and that's going to be, again, negative 44 like we had up here. And that's going to be meters. And this is in seconds. This is my horizontal axis, which is in seconds. This is my vertical axis, which is in meters. It's going to be 4 seconds. So you can see we've got negative 11. That's going to be meters per second. Negative 11 meters per second. And that's going to be your average velocity. Then find the instantaneous velocity. Well, remember, the instantaneous velocity is just v of t. And v of t equals the derivative of the position function ds dt. And that's just going to be the derivative of this polynomial, which is very easy. That's going to be 3t squared minus 16t plus 5. And we want to find the instantaneous velocity when t is 2. Right over here, c. So we want to find v of 2. So that's going to be 3 times 2 squared minus 16 times 2 plus 5. 2 squared is 4, 3 times 4 is 12, minus 32 plus 5, that's going to be negative 20, plus 5 is going to be negative 15. That's going to be meters per second also. So negative 15 meters per second. And then letter D. Letter D is what is the acceleration at 3 seconds. So remember, acceleration as a function of time equals dv dt, the derivative of the velocity. And what's that going to be? There's my velocity, so if I take the derivative, that's another polynomial, which is easy. 6t minus 16. And we're going to be looking for, let me move this a little bit here. So we're going to be looking for a of what? 3. So we'll just put 3 in here. 6 times 3 minus 16. And that's going to be 18 minus 16. And that's just going to be 2. And that's going to be meters. And my units for acceleration would be per second squared. Okay. That's the slope of the velocity. So the velocity would be meters per second, and the slope would be meters per second over seconds, which is meters per second squared. Okay, letter E, A, B, C, D, E. For what values of t does the particle change directions? So we can first of all find out, we know if in order to change directions it's going to have to stop, so we're going to have to set it equal to 0 to find out when it stops. So we'll say velocity equals 0 when 3t squared minus 16t plus 5 equals 0. And we'll try to factor this. This is a nice factorable trinomial, I think. The signs are both the same, saying they're both going to be negative, so I can put negative, negative. There's only one way to get 5, 5 and 1, so either 1 goes here or 5 goes here, and it actually ends up being 1 and 5. And you can check it, 3t. Negative 15 and negative 1 is negative 16 and positive 5, so that checks out. So we know that t would equal 1/3, or t would equal 5. Now, that's where it stops. It could stop and keep going, so we want to check it. So what we'll do is we'll make a little graph here. And this is actually going to help us for the other two questions, the next two questions. So this would be the velocity as a function of time. And in order to change directions, in order to change directions, if you're moving right, in order to move left, you've got to stop for a moment. So this is going to be, this time will be 0 here. And this would be 1/3. Let's do it over here. And let's say this is 5. Okay. Well, my scale may be a little bit off. Now let's see what the velocity is in these intervals, because this is where it stops, so it's going to be going one way or the other. Well, when t is 1/3, let's see, let's try something a little smaller than 1/3. Let's try 1/4. If I put 1/4 in here, that's going to be 3/4. That's going to be negative, and that's going to be negative. I can put it in here. 1/4 minus 5 is negative, and 3/4 minus 1 is negative, and negative times a negative is a positive, so I got a positive here. And if my velocity is positive, that means I'm moving to the right. Now let's put 1 in here. If I put 1, well, I could put 1 in. 3 times 1 is 3, minus 1 is positive, but 1 minus 5 is negative, so I got a positive times a negative, so this is going to be negative in here. So that means I'm moving to the left. And then I can put 6 in here, and this would be positive, and that would be positive, so I've got a positive. That means I'm moving to the right. So the question was, for what values of t does the particle change direction? So it changes direction at t equals, I can write it over here, I guess. Right over here, t equals 1/3 and t equals 5. And that would be in seconds. So you can see that. That answers E. And then for letter F, during what time intervals is the particle moving right? Well, we've already got that, because we needed to do that just to check. So it's moving right. So it's moving right whenever this is positive. So this is positive from 0 and this is kind of, well, it does say when the time is 0, the velocity is positive, but it's really not moving when time is 0. So you could put a parenthesis here because we haven't started our clock yet. So but you could put a bracket if you want to think about that. It's kind of debatable there. So it's going to go from 0 to 1/3, and then it's also moving right from 5 on out to infinity. And when is it moving left? That was letter G. What time intervals is it moving left? G. It's moving left between 1/3 and 5. And that's when it's moving left. Okay, so a little line graph like this helps quite a bit. Okay.